The hyoid bone is a slender U-shaped bone. It's suspended just beneath the mandible. It isn't directly attached to any other bone. You can feel your own hyoid bone here, and you can move it from side to side. Together with its attached muscles, the hyoid bone has two important functions. It holds up the tongue, which sits above it, and it holds up the larynx, which hangs below it. It also transmits the force of muscles that help to open the jaw. Let's take a closer look at the hyoid bone. This broad central part is the body. Its forward-facing upper surface is convex, with facets for the attachment of numerous muscles that we'll see shortly. The backward-facing lower surface of the body is deeply concave. On each side, this long, slender part of the hyoid bone is the greater horn, or greater cornu. The greater horn is attached to the body by a small synovial joint, which gives it a little mobility. This small projection is the lesser horn, or lesser cornu. When the structures above and below it are at rest, the hyoid bone lies slightly below the lower border of the mandible. In the frontal plane, the body of the hyoid is about in line with the last molar tooth. From its resting position, the hyoid bone can be moved upwards and downwards, and forwards and backwards, by the muscles that are attached to it. Now, we'll look at the muscles that hold the hyoid bone in place and cause it to move. There are 7 pairs of them. 2 that pull the hyoid bone upwards and forwards, 1 that pulls it upwards and backwards, 1 that pulls it upwards by means of a pulley, and 3 that pull it downwards. We'll start with the 2 that pull upwards and forwards, the mylohyoid and geniohyoid muscles. Here are the 2 mylohyoid muscles. Between them, they form a continuous sling of muscle that forms the mobile floor of the oral cavity. The mylohyoid muscle arises from the mylohyoid line on the mandible. Most of its fibers pass downwards and medially, joining in the midline with the fibers from the opposite side, all the way from the symphysis of the mandible to the body of the hyoid bone. The more posterior fibers of the mylohyoid insert here on the body of the hyoid bone. The mylohyoid muscle has a free posterior border, which runs straight downwards when seen from the side, also a little inward when seen from behind. Now we'll add the 2 geniohyoid muscles to the picture. Here they are. They lie above the mylohyoid. On each side, the geniohyoid arises from the lower part of the mental spine. It inserts here, on the body of the hyoid bone. Now we'll bring the base of the skull into the picture and add the muscle that pulls upwards and backwards, the stylohyoid. Here's the stylohyoid. It's a long, slender muscle. Just above its insertion, there's an opening in the stylohyoid. The digastric muscle passes through this opening, as we'll see. The stylohyoid arises from the lateral aspect of the styloid process. It's inserted on the base of the greater horn of the hyoid bone. Next we'll add the digastric muscle to the picture. Here it is. The digastric muscle is unusual in that it has 2 bellies, an anterior and a posterior, that are connected in the middle by a tendon. The posterior belly of the digastric arises here, from the digastric notch on the underside of the temporal bone, and from the medial aspect of the mastoid process. The origins of the sternocleidomastoid and splenius muscles, which have been removed in this dissection, lie lateral to it. The posterior belly narrows to a tendon which passes between the 2 slips of the stylohyoid. The digastric tendon then passes through a sling of fibrous connective tissue, by which it's tethered to the hyoid bone, here. The tendon then broadens out into the anterior belly of the digastric, which runs almost straight forward beneath the mylohyoid. It's attached low down on the inner aspect of the body of the mandible, just lateral to the midline. Lastly, we'll take a brief look at the attachments of the 3 muscles that pull the hyoid bone downwards. They're the omohyoid, sternohyoid, and thyrohyoid muscles, known collectively as the infrahyoid muscles. Here's the body of the hyoid bone. Here's the upper end of the omohyoid muscle, which goes all the way down to the scapula. Medial to it is the sternohyoid muscle, which goes to the sternum. Behind these two is the short thyrohyoid muscle, which goes down to a structure we haven't seen yet, the thyroid cartilage. These muscles insert on the edge of the body of the hyoid bone, the thyrohyoid here, the omohyoid here, and the sternohyoid here. We'll see these three muscles more fully later in this tape. The infrahyoid muscles pull the hyoid bone downwards. Acting together with the digastric muscle, the infrahyoid muscles assist in opening the jaw. The actions of the other hyoid muscles that we've seen are evident from the direction of their fibers. Now that we've seen the hyoid bone and the muscles that hold it in place and move it, we'll move on to look at the tongue. The shape of the mobile anterior part of the tongue is familiar to us from everyday encounters. What's perhaps surprising is how much of the tongue we don't see from in front. The tongue goes a long way back and a long way down. To understand the overall shape of the tongue, let's look at a specimen that's been divided in the midline. All this is the tongue, right back to here. The tongue consists almost entirely of muscle, covered by specialized mucous membrane. The freely mobile anterior part of the tongue almost fills the oral cavity. The massive posterior part of the tongue, which is much less mobile, faces backwards into the oropharynx. This structure below and behind the back of the tongue is the epiglottis. We'll see it in the next section. To get a look at the intact tongue, we'll look at a specimen consisting of just the tongue, the mandible, and the hyoid bone. Here's the mylohyoid muscle. The body of the hyoid bone is here. Here's the greater horn. We'll look at the outside of the tongue first. The tongue is covered with mucous membrane on top, on the sides, and also here in front on the underside. The mucous membrane of the tongue is continuous with the mucous membrane that covers the floor of the mouth and the alveolar process. There's a deep valley between the alveolar process and the side of the tongue. This projecting fold in the midline is the frenum. On either side of it, the submandibular ducts open, as we'll see later. The mucous membrane over the root of the tongue is thin and mobile. Over the sides and the upper surface, the mucous membrane is thick, firmly attached to the underlying muscle, and covered by projections, called papillae. The largest of these, the valleculate papillae, are in a row back here. This shallow pit in the midline is the foramen caecum. The muscles that form the bulk of the tongue are intrinsic muscles, which run from one part of the tongue to another, and extrinsic muscles, which are attached to bone. There are 3 extrinsic muscles on each side. Of these, the 2 largest, which we'll see now, are hyoglossus and genioglossus. The other one, styloglossus, we'll see later. To get a view of the major extrinsic muscles, we'll divide the mandible along this line and remove the ramus and the alveolar process. We'll also remove all of the mucous membrane from this line downwards. Here are the hyoglossus and genioglossus muscles, which together form the root of the tongue. To see the full extent of genioglossus, we'll remove hyoglossus for a moment. All this is genioglossus. Genioglossus arises just above the geniohyoid from the upper part of the mental spine. Its fibers fan out. The the highest ones arching forward almost to the tip of the tongue, the lowest ones running straight backward to the most posterior part of the tongue. Genioglossus compacts the tongue and pulls it forwards. Now we'll put hyoglossus back in the picture. Hyoglossus is a thin, flat sheet of muscle. Its fibers run upwards and forwards. Hyoglossus arises from the whole length of the greater horn of the hyoid bone. Here's the greater horn, and ends here along the side of the tongue. Hyoglossus flattens the tongue and pulls it backwards and downwards. Here alongside hyoglossus is the third extrinsic tongue muscle, styloglossus, coming in from behind. We'll see it later. Here's the mylohyoid muscle, seen from behind. The space between the mylohyoid and hyoglossus muscles is the pathway for the nerves to the tongue and the submandibular duct, as we'll see in the next tape. The intrinsic muscles of the tongue, which we won't look at in detail, run both longitudinally and transversely above and between the extrinsic muscles. They're responsible for many of the fine movements that are involved in handling food and in speech. We've looked at a lot of muscles in this section: the muscles of mastication, the muscles of the hyoid bone, and the extrinsic tongue muscles. Later in this section, when we look at the salivary glands and at the pharynx, we'll have a chance to see how all the muscles fit together that we've seen up to now. Before we move on, let's review the structures that we've seen so far in this section. Here's the ramus of the mandible. Here's the body, formed by the alveolar process and the base. Here's the angle, the condyle, the neck, the coronoid process, and the mandibular notch. Here are the symphysis, the mental protuberance, the buttress, the mandibular foramen, the lingula, the mylohyoid line, the submandibular fossa, and the mental spine. Here's the temporomandibular joint, the articular disc, the stylomandibular ligament, and the sphenomandibular ligament. Here are the lateral pterygoid muscle, the medial pterygoid muscle, the temporalis, and the masseter. On the hyoid bone, here's the body, the greater horn, and the lesser horn. Here are the mylohyoid muscles, the geniohyoid, the stylohyoid, the digastric, the omohyoid, sternohyoid, and the thyrohyoid. Here's the genioglossus muscle, and here's the hyoglossus. Now we'll move on to take an overall look at the oral cavity and at some important closely related structures. We'll look first at the shape and extent of the oral cavity. Then we'll look at the muscles of the cheek and lips, then at the teeth, then at the salivary glands. To understand the shape of the oral cavity and its extent, we'll look at it in a living model. Here's the tongue, here's the palate, here's the inner aspect of the alveolar process of the maxilla and of the mandible. The alveolar processes of the maxilla and mandible, together with the upper and lower teeth, project into the oral cavity from above and below. They divide the oral cavity into an inner part and an outer part. The upper and lower gums, or gingivae, are formed by mucous membrane that covers the alveolar processes on the outside and on the inside. The outer part of the oral cavity, the vestibule, lies between the teeth and gums on the inside and the cheek and lips on the outside. The mucous membrane of the lips and cheek is continuous above and below with the mucous membrane of the gums. The inner part of the cavity is closed off above by the hard palate and further back by the soft palate, which ends back here at the uvula. It's closed off below largely by the tongue and also by the mucous membrane of the floor of the mouth. To see the features of the posterior part of the oral cavity, we'll look at a dissected specimen that's been divided in the midline. This specimen is missing a number of teeth. The mucous membrane that lines the cheek passes medially behind the last molar teeth and becomes continuous with the mucous membrane of the inner part of the oral cavity. The front of the ramus of the mandible is here. To look at the wall of the oral cavity further back, we'll move the soft palate backward. This fold in the mucous membrane, running from the soft palate to the side of the tongue, is the palatoglossal arch. It acts as a dam, preventing liquid from spilling backward past the side of the tongue. This less noticeable fold is the palatopharyngeal arch. This triangle between the two arches is occupied in early life by a prominent mass of lymphoid tissue, the tonsil. In later life, as in this specimen, the tonsil atrophies. Here's the palatoglossal arch in a young person. Here behind it is the tonsil. We'll look at the soft palate along with the pharynx at the end of this section. Now that we've looked at the overall shape of the oral cavity, we'll move on to look at the muscles of the cheek and lips. The muscles we'll look at are the buccinator, which forms the muscular lining of the cheek, and the complex of muscles that surround the mouth, collectively called the orbicularis oris. Before looking at these muscles, we need to get acquainted with a ligamentous structure that the posterior fibers of the buccinator are attached to, the pterygomandibular band, also called the pterygomandibular raphe. The pterygomandibular band, represented by this piece of material, passes from the pterygoid hamulus to the posterior end of the mylohyoid line. Two muscles arise from it, the buccinator in front and the superior constrictor of the pharynx behind. The pterygomandibular band can stretch to accommodate jaw movement. Now, to see the muscles of the cheek and lips, we'll look at a dissection in which the skin and subcutaneous fat have been removed from the lower part of the face. The muscles of facial expression have also been removed. Here's the orbicularis oris. Here's the buccinator. The two are closely associated. We'll look at the buccinator first. Here it's partly hidden by the masseter muscle, which we'll remove. The buccinator is a thin pouch of muscle that closely follows the contours of the mucous membrane of the vestibule. It has a long line of origin. The buccinator arises from the maxilla and from the mandible along these lines. Above, the line of attachment curls round behind the tuber of the maxilla. Below, it curls round onto the buttress of the mandible. Between these 2 points, the most posterior fibers of the buccinator arise from the pterygomandibular band. The buccinator muscle passes forward and divides at the corner of the mouth. Its fibers continue forwards to become the deepest part of the orbicularis oris. The orbicularis oris muscle complex surrounds the opening of the mouth. It consists partly of intrinsic fibers, but it's formed mainly by the fibers of other muscles, on the deep aspect by the continuing fibers of the buccinator, and on a more superficial level by these muscles of facial expression. We'll take a good look at them in the last section of this tape. The action of the orbicularis muscle is to press the lips together, closing the mouth. The action of the buccinator is to prevent the cheek from distending when we raise our intraoral pressure. When we let the buccinators relax, this happens. Now that we've looked at the muscles of the cheek and lips, we'll move on to look at the teeth. These are the lower teeth of a young adult. In the full dentition, there are 16 teeth above and 16 below, 32 in all. In each quadrant, there are 2 incisors, 1 canine, 2 premolars, and 3 molars. This individual's 3rd molars have been removed. The incisor teeth are flat and chisel-shaped. The canine teeth have a crown that's cone-shaped and a massive root which forms a prominence in the gum. The premolar teeth are broad and short from front to back. They have 2 projecting cusps. The molars are longer from front to back than the premolars and have from 3 to 5 cusps. Each tooth consists of a crown, which projects above the gingiva, and a root or roots which are embedded in bone. The tip of the root is called the apex. The crown and the root meet at this slight narrowing, the neck. The crown is covered on the outside with enamel, which is extremely hard. The inner part of the crown and the root are made of dentin. The tooth is fixed to the surrounding bone by a layer of specialized periosteum, the periodontal membrane or ligament. The space within the tooth is the pulp cavity. The pulp of the tooth contains blood vessels and nerves, which enter through the apical canal. The incisors and canines have 1 root. The premolars have a single root that's forked at the end. The molar teeth have multiple roots. The upper ones have 3. The lower ones usually have 2. Now that we've looked at the teeth, we'll move on to look at the glands that produce saliva, the salivary glands. There are 3 salivary glands: the parotid gland on the side of the face, the submandibular gland beneath the body of the mandible, and the sublingual gland in the floor of the mouth. We'll look at the parotid gland first. Part of the parotid gland lies superficially in the posterior part of the cheek. Part of it lies deep in the space between the ramus of the mandible and the sternocleidomastoid muscle. We'll look at the deep part first. To look at the deep part of the parotid gland, we'll start with a dissection in which the whole of the gland has been removed. This is a good opportunity to see, all in one place, a number of structures that we've learned about separately. Let's take a good look round. Here's the posterior border of the ramus of the mandible. Here's the zygomatic arch. Here's the external auditory meatus. Here's the mastoid process. Here's the sternocleidomastoid muscle. Here's the masseter muscle. Here's the space that's occupied by the deep part of the parotid gland. Here's the posterior belly of the digastric muscle lying deep to the sternocleidomastoid. Here's the styloid process and the stylohyoid muscle. Here, emerging behind the styloid process, is the trunk of an important nerve, the facial nerve. The facial nerve, which provides the motor innervation to all the muscles of facial expression, has an important relationship to the parotid gland. It runs right through it, dividing into several branches as it does so. Now that we've seen the space that's occupied by the deep part of the parotid gland, we'll add the deep part of the gland to the picture. Here's the cut surface of the parotid gland. Again, here are the sternocleidomastoid muscle, the masseter, and the ramus of the mandible. Before we add the superficial part of the parotid gland, we'll add the facial nerve to the picture. Here's the trunk of the facial nerve, entering the parotid gland from behind. The branches of the facial nerve fan out, upwards, forwards, and downwards. We'll take a more complete look at the facial nerve in the next tape in the series. Here, we're concerned only with its relationship to the parotid gland. Now we'll add the superficial part of the gland to the picture. Here it is. The superficial part of the parotid gland covers the posterior part of the masseter muscle. Its extent varies. It usually extends up as far as the zygomatic arch and down to the angle of the mandible. It can also overlap the anterior border of the sternocleidomastoid muscle. The saliva that's secreted by the parotid gland passes into the parotid duct, which emerges from the anterior border of the gland and passes forward around the anterior border of the masseter. The parotid duct enters the oral cavity by passing through the buccinator muscle and through the underlying mucous membrane, at about the level of the second upper molar tooth. Next, we'll look at the submandibular gland. The submandibular gland lies under the posterior part of the body of the mandible. We'll start by looking at a dissection in which the gland has been removed. Again, we'll take the opportunity to review the bony and muscular anatomy. Here's the body of the mandible. Here's the body of the hyoid bone. Here's the anterior belly of the digastric. Here's the digastric tendon passing through the stylohyoid muscle. Here's the mylohyoid muscle. Here's the styloglossus. Here, deep to the digastric, is the hyoglossus muscle. Now we'll add the submandibular gland to the picture. Here it is. The submandibular gland curls around behind the free border of the mylohyoid muscle so that it has a superficial part, which we can see here, and a deep part. To see the deep part, we'll remove the superficial part. Here's the cut edge of the deep part of the submandibular gland, between the mylohyoid and styloglossus muscles. It extends forward to about here. The saliva that's produced by the submandibular gland passes into the submandibular duct, which runs forwards in the floor of the mouth. To see the duct, and also to see the third salivary gland, the sublingual gland, we'll look at a specimen consisting of the mandible, the tongue, and the floor of the mouth. We'll remove the alveolar process, and we'll remove the mucous membrane. Here, just beneath the mucous membrane, is the sublingual gland, which we'll see in a moment. For now, we'll remove it too, to see the submandibular duct. The submandibular duct runs forward in the floor of the mouth, alongside the base of the tongue. It ends here, just beside the frenum. To see where it starts, we'll go round to the back. Here's the submandibular duct. Here's the submandibular gland. The duct passes forward in the interval between the mylohyoid muscle and the muscles of the side of the tongue, the hyo and styloglossus muscles. Now, we'll go round to the front again and put the sublingual gland back in the picture. The sublingual gland is thin, flat, and somewhat diffuse. It lies alongside the base of the tongue, just lateral to the genioglossus muscle. The saliva formed by the sublingual gland enters the oral cavity by way of several very small openings in the mucous membrane of the floor of the mouth. The openings are too small to see here. Now that we've looked at the salivary glands, we'll move on to complete our picture of the structures around the oral cavity by looking at the pharynx. To understand the lower part of the pharynx, we need to look at two important structures that we haven't seen yet, the thyroid cartilage and the cricoid cartilage. The thyroid cartilage is here, below the hyoid bone. The cricoid cartilage is here, just below the thyroid cartilage. Here are the thyroid cartilage and the cricoid cartilage together. The cricoid cartilage is partly enclosed by the larger thyroid cartilage. We'll look at the thyroid cartilage first. The thyroid cartilage consists of two slightly curved plates, the laminae. The laminae are joined together in front. They're widely separated behind. The laminae meet at an angle of 120 degrees in the female, 90 degrees in the male. This is a female specimen. In the male, the thyroid cartilage projects forwards, giving rise to the laryngeal prominence, also known as the Adam's apple. Above, the two laminae meet in a V-shaped notch, the superior thyroid notch, that's easy to feel, just above the laryngeal prominence. On the sides of the lamina are two projections, the superior and inferior tubercles. They're joined by this slight ridge, the oblique line, which is a major muscle attachment, as we'll see. The posterior border of each lamina is prolonged upward and downward, to form two projections, the superior horn and the inferior horn. The superior horn points upwards and backwards, the inferior horn points downwards. The thyroid cartilage hangs directly below the hyoid bone. The upper border of the thyroid cartilage has the same curvature as the arch of the hyoid bone. The thyroid cartilage is suspended from the hyoid bone by this membrane, the thyrohyoid membrane. On each side, the posterior part of the membrane is thickened, forming the lateral thyrohyoid ligament. The inferior horn of the thyroid cartilage articulates with the cricoid cartilage at the cricothyroid joint. Unlike the thyroid cartilage, which is open at the back, the cricoid cartilage forms a complete ring. Let's look at the cricoid cartilage by itself. It's much taller behind than in front. The narrow part in front is the arch. The tall part behind is the lamina. The inferior horn of the thyroid cartilage articulates here. Below, the cricoid cartilage is continuous with the upper end of the trachea. The cricoid and thyroid cartilages form the framework for the larynx. We'll see them in that context in the next section of this tape. We're concerned with them in this section because they also give attachment to some important muscles of the lower part of the pharynx. Now that we've seen them, let's look at the pharynx. To get a view of the pharynx from the side, we'll start with a dissection in which all the neck muscles are present. The only parts of the pharynx we can see are here and here. To get a better view, we'll remove the sternocleidomastoid muscle. We'll also remove all the underlying nerves and blood vessels. Here, just in front of the vertebral column, are the longus capitis and longus cervicis muscles. Here, below them, are the scalene muscles. Here's the lower half of the pharynx. The pharynx lies just in front of the longus muscles. To see the whole of the pharynx from behind, we'll remove the vertebral column and all the neck muscles. Here's the pharynx. The pharynx extends from the base of the occiput to the level of the top of the clavicle. The upper part of the pharynx is partly hidden by the digastric muscle, which we'll remove. The upper part of the pharynx is hidden also by the styloid process and the three muscles that descend from it, stylohyoid, which we'll remove, and two other slender muscles which we'll meet shortly, styloglossus and stylopharyngeus. For now, we'll remove them too, along with the styloid process. Now we can finally get a clear view of the whole of the pharynx. Here above the pharynx is the base of the occiput. These are the occipital condyles. Here's the medial pterygoid muscle, sloping downwards from the medial pterygoid plate, which is here. The wall of the pharynx is formed by an almost continuous layer of muscle, lined by mucous membrane. The muscular layer consists of three sheets of muscle, the constrictor muscles, superior, middle, and inferior. These overlap behind, the one above inside the one below. Here's the inferior constrictor. Here's the middle constrictor. Here's the superior constrictor. The superior constrictor is very thin. Its fibers arise from the lower part of the medial pterygoid plate, the hamulus, and the pterygomandibular band, and also from the side of the tongue. The superior constrictor has a free upper border. Above this, the wall of the pharynx is formed by this layer of fascia, the pharyngobasilar fascia. The highest fibers of the superior constrictor insert on the base of the occipital bone. The remaining fibers meet in the midline with the fibers from the opposite side, extending down to here, inside the middle constrictor. Here's the middle constrictor. It's a thicker muscle. The middle constrictor arises from the lesser horn and the greater horn of the hyoid bone. Here's the tip of the greater horn of the hyoid bone. Here's the edge of the lateral thyrohyoid ligament. The fibers of the middle constrictor fan out, meeting with those of the opposite side from here down to here inside the inferior constrictor. Here's the upper border of the inferior constrictor. It's thicker again than the middle constrictor. The inferior constrictor arises from just behind the oblique line on the thyroid cartilage, and also from the side of the cricoid cartilage. Its fibers fan out, meeting with the fibers from the other side, all the way from here down to here. The lower end of the inferior constrictor muscle is continuous with the muscular coat of the esophagus. The lowest part of the inferior constrictor, which is functionally separate from the rest of the muscle, is referred to as the cricopharyngeus muscle. It forms a sphincter round the upper end of the esophagus. To complete our picture of the upper part of the pharynx, we'll put the styloid process back, along with two of its three muscles. The longer one is styloglossus, the shorter one is stylopharyngeus. Stylopharyngeus runs down outside the superior constrictor and passes into the wall of the pharynx between the superior and middle constrictors. Styloglossus passes downwards and forwards alongside the superior constrictor and enters the posterior part of the tongue, joining with hyoglossus. To complete our picture of the pharynx, we'll look at a specimen that's been divided in the midline. Looking at the pharynx from the inside will also let us see the muscles of the palate that we left out of the picture in the previous section. Here's the pharynx. Throughout its length, the back wall of the pharynx lies just in front of the vertebral bodies and the longest muscles, with a layer of loose fascia in between that permits movement. The pharynx opens forwards into the nasal cavity, the oral cavity, and the larynx. Up here, it opens laterally into the auditory tube, as we've seen. Down here, it opens downward into the esophagus. The pharynx is often described in three parts: the nasopharynx, which we've looked at already, the oropharynx, and the hypopharynx, also sometimes called the laryngopharynx. The muscles of the palate that we haven't seen yet lie directly beneath the mucosa, which we'll remove. Here's palatoglossus. It arises here from the palatal aponeurosis and passes downwards and forwards to insert on the side of the tongue. Palatoglossus pulls the soft palate downward and forward. Here's palatopharyngeus. It arises partly from the edge of the hard palate, partly from the palatal aponeurosis. Palatopharyngeus passes downwards and backwards to blend with an almost continuous layer of longitudinal muscle that lines the lower part of the pharynx. The lowest fibers of palatopharyngeus insert here on the posterior border of the thyroid cartilage. The palatopharyngeus muscle lies inside the constrictor muscles, hiding them almost completely in this medial view. From here, we see only the upper part of the superior constrictor. We'll take a closer look at it. Here's the upper free border of the superior constrictor muscle. Coming in towards us from above are structures that we met earlier in this tape: the levator palati muscle, the tensor palati muscle, and the cartilage of the auditory tube. Now let's review what we've seen of the oral cavity, the muscles of the cheek and lips, the teeth, the salivary glands, and the pharynx. Here are the gingivae, the hard palate, the soft palate, and the uvula. Here are the palatoglossal arch and the palatopharyngeal arch. Here's the tonsil. Here's the pterygomandibular band, the buccinator muscle, and the orbicularis oris muscle. Here are the teeth, the incisors, the canine, the premolars, and the molars. Here's the crown of the tooth, the root, and the apex. Here's the neck, here's the pulp cavity, here's the apical canal, and the periodontal membrane. Here's the parotid gland, and the parotid duct. Here's the submandibular gland, and its duct. Here's the sublingual gland. Here's the thyroid cartilage. Here's the cricoid cartilage. Here are the superior constrictor, the middle constrictor, and the inferior constrictor. Here's styloglossus and stylopharyngeus. Here's palatoglossus and palatopharyngeus. That brings us to the end of this long section on the oral cavity and the structures that surround it. In the next section, we'll look at the larynx and its surrounding structures.